Okay. So guys, today we'll have a look at 5D.2. It's a pretty short one. There's only 2 questions, and it's like the skill is easy. What the skill is, but let's try and make sense of it. What is it that we're doing? Let's try and bring it in with regards to the unit circle and what we're doing with the unit circle. So firstly, here's a question for you. On the unit circle, let's say I have a point on the unit circle and its position is dictated by this angle, and the angle is 63 degrees. How can I determine the coordinates of that point?
Sine given cosine here.
Very good. So the y coordinate is going to be sine 63. So if I have my calculator set in degrees and I type in sine 63, that's going to be the y value, and cos 63 is going to be the x value. Very good, okay? So we can go from an angle to a coordinate from our calculators, right? What we're going to do today is we're going to start with a coordinate and go back to an angle, all right? So if I have sine theta equals 0.453, that means the y value on the unit circle is 0.453. So you can think about it. Here's the unit circle. It's on the Cartesian plane. And the y value is 0.453. So that's going to be like here somewhere, right? It's just below 0.5. What are the positions on the unit circle that correspond with that y value? It's here and here. Okay, they are the 2 locations that have a y coordinate of 0.453. Now we're not given the x coordinate and we're not asked to calculate it, but if we wanted to, all right, we could quite easily. Remember, cos squared theta plus sine squared theta equals 1. Here you've got the sine value, you can plug it in there and process for the x value. So we could quite easily determine the x value. All right, but we're asked, what are the angles? So firstly, that's going to be our first angle. And then this one here, all right, all inclusive is going to be our second angle. So the way we determine that in our calculator is we just go, now in the first one it says degrees, all right? So we're going to be alternating between the 2. So remember I said, make sure you're competent at changing the setting. So just to reflect on that, it's shift, menu, and you scroll down to where it says angle. And depending on what the question says, that's going to dictate what setting you need to have. All right, so here it says degrees. So what we're going to do, we're going to type in inverse sine, and then our the size of the y value is 0.453. So we press shift sine. That brings up the inverse sine, right? 0.453. Right here. All right, we've got 26.9.94. Let's just talk about rounding quickly, actually. We've got 26. When we round, okay, if you look on the front of all of your tests, it says round to 3 significant figures unless otherwise stated. That means you write 4 and you round the third one, okay? 3 is less than 5, so this number stays as 26.9 degrees. That's the first angle. And in fact, we could refer to it as theta subscript 1. Okay? Now, who wants to take a wild guess? Is that describing this position, the first position, or the second position? Has to be the first, right? It's 26.9 degrees. That's within the first quadrant. The first quadrant is 0 to 90, so that's the first position. Now, the way we determine the other position is in our notes book, we've got a list of formulas at the top. Okay? In degrees. All right, sine of 180 take theta equals sine of theta. Okay, so we've got 26.9 is our first angle. So that means our second angle is going to be 180 take 26.9. All right, so we're going to write that out. Theta 2, the angle in the second quadrant, 180 take the angle we obtained here, 26.9. Evaluate that. Okay, so let's reflect on, like, here's the skill, right? In your calculator, you go inverse sine, you get the first angle, and then you just get the second angle by referring to the formula. That's what we're doing, okay? The thing you need to consider, what does it mean for the unit circle? Let's move on to the second one. Find two angles in radians. Okay, so we need to change our calculator. We've got cos theta is minus 0.921. So if I'm drawing that on the unit circle, cos is my x values, minus 0.9, that's going to be like over here. The x value is minus 0.921. What are the coordinates on the unit circle that correspond with that x value? Here and here. They're in the third quadrant and the second quadrant, right? So here, the x value is minus 0.921. We don't know the y value. We're not asked to find it, that's fine. And then the same with this position as well. We don't know the y value. But we're finding this angle, theta 1, and then we're finding this angle, theta 2, the whole way around, in radians. So what we'll do, set our calculator to radians, inverse cos of minus 0.921. I didn't change it to radians, sorry. 2.74, thank you. 2.741. All right, and for radians, of course, intuitively, we use the letter C. Perfect. All right, so that's our first angle. All right, and remember, what does that mean? It means if the radius is 1, you have to travel 2.74 units, and that's how big the angle is. 2.74 units in an arc. Okay, for theta 2, all right, we've got cos, we've got it in radians, so we refer to our notes book here, that the equivalent angle is 2 pi, take away the angle that we found, okay? So theta 2 is going to be 2 pi, take 2.74. So that's what we're going to put in our calculator. So 2 pi, pi is at the bottom of our calculator where we've got the times 10 or EXP, might be depending on the version you have, and you press shift times 10 to bring up pi. So we're going to have 2 pi, take 2.74, 3.543. C for radians. Very good. There's a bit of room here. Okay, last one. We have tan theta equals 7. All right, tan theta equals 7. So this one's a bit harder for us to picture, but I know roughly where it's taking place. Okay? Because tan is sine divided by cos, and we're told tan theta is 7 and it's positive. So remember, all students talk cool. All right, so tan is positive in the first quadrant and the fourth quadrant. So I know it's taking place in those regions. All right, the other thing is it's larger than 1, okay? So here is where tan is 1, and so it's got to take place somewhere in between there. All right, in fact, tan is 7, so it's going to be somewhere in here and somewhere in here. All right. So let's figure out what it's going to be. 2 angles in degrees. So what we'll go to set our calculator back to degrees. Inverse tan of 7. Let's calculate the first angle. All right, I've got 81.86 degrees. Okay, pretty close to where I predicted it was going to be. 81.86, which rounds to 81.9. So this is a good example. We write 4 figures, we round the 4th one. All right, And what's good about this method is you don't even need to consider any more than that. Always write 4 figures, and that one, does it round up or down? That's going to dictate our final answer. So that's theta 1. And then for theta 2, okay, we've got tan and we've got degrees. What's it say? Theta 2 is equal to 180 plus 81.9. All right, so that's all you're doing, okay, in this exercise. So I would say just do a few from question 1, a few from question 2, and then we'll move on to E, all right? If I can say one thing, it's that try keep in mind, like what is it that I am finding here? I'm trying to determine the angles. And if you feel like it, try and understand why is it that sine of 180 take theta equals sine of theta? Cos of 360 take theta equals cos of theta, okay? Why is it that that statement is true? Won't be something I explain to the whole class, because it's not something we need to know, but something to consider. All right, just question 1 and 2, let's do a few from each.